Good morning everyone. So the topic of today is vectors. So in my teaching experience, I have seen so many students, they are so afraid of this topic vectors, and till now I'm not able to figure out that why students are so afraid of this topic vectors. They even get afraid by the name of the vectors. So today's topic is vectors, and before stepping on to the questions, first of all I want you people to clear your basics. So first of all, we'll go from the very starting, from the very scratch. It is very much beneficial for all the students who haven't studied vectors yet. So yes, we are going from the very scratch. So the first term for today is vector. Now what is a vector? So those of the students who have studied this word in physics, they might be knowing this, that a vector is a quantity which has direction as well as magnitude. Okay, so this is the basic definition. Now what? Did you get that? Did you get what I said? If you are a novice, if you haven't read about this word before, no, right? So let's proceed to what a vector basically is. So first of all, how we represent a vector, or what actually a vector is. Okay, so if we call this line, this AB, and okay, I'll tell you, this is a vector. Now what? Vector is a physical quantity that has direction as well as magnitude. Okay, if I consider this marker which I'm having in my hand, so if somebody asks me, so what is the weight of this marker, then what will I say? I'll say, okay, it's of 10 grams. Do I say in the direction of right or in the direction of left? 10 grams in the north direction or 10 grams in the south direction? No, right? Nobody says like that, and that's how it goes. It shouldn't be said like that. So what actually is a vector quantity? So if I have a marker over here right in front of me, and if I apply 10 newtons of force to this marker, and the marker moves in my left direction, right? Once again, if there is a marker and if I'm applying a force of 10 newtons to this marker and the marker moves in this left direction of mine, so then I would say that this marker, for example, this is the marker here, and I am applying a force of 10 newtons and the marker from here, it moved till here in the right direction. So now I will say that when I applied 10 newtons of force and the marker moved from here to here, so this length will be of 10 units in the direction, like in this direction, sorry, 10 units in the right direction, right? So now it becomes a vector quantity. Like I applied a force of 10 newtons in the right direction, so now the magnitude of the vector will be 10 units. Like I applied a force of 10 units, so the length of this vector or the magnitude of this vector will be 10 units and in the right direction. And now we can say that a 10 newton of force was applied on the marker, it moved 10 units, so the magnitude of this vector is 10 units in the right direction. So now this is a vector quantity, as it has magnitude which is 10 units and the direction which is very much the right direction. So this is what a vector is. Okay, so now stepping on to our next definition for today is scalar. What is a scalar quantity? So before stepping on to the scalar quantity, I want to tell you that some of you must have studied this chapter in physics also. Alright, so in physics you must have heard about the physical quantities. Okay, so what basically are physical quantities? The quantities which can be measured are known as the physical quantities, right? Any quantity which can be measured, the quantity which is measurable, is known as a physical quantities. And in the physical quantities are divided into two segments. First one is the vector and second one is the scalar. Okay, some of you might be knowing about the very third quantity, which is the tensor, but that's not the point of point of discussion right now, since you're in 12th class. So our very second quantity is the scalar quantity. Now, what is a scalar quantity? Now, the students will say, or some of you have heard it, this quantities which has only the magnitude but not the direction, right? The quantity which only has the magnitude but not the direction. For example, when at the very first place I asked you what is the weight of this marker, then somebody told me that the weight of this marker is just 10 grams. Right? We didn't say in the right direction or in the left direction. So now it has become a scalar quantity, right? We only have the magnitude of this marker, that is the 10 gram. The weight of this marker is 10 grams, just the magnitude or just the value. So what basically magnitude is? Magnitude means the value or the length or the weight or anything which is measurable, right? So now the magnitude of this marker is 10 grams, but it doesn't have any direction. Like if it is kept here in the north direction, even then its weight is 10 grams. If we keep it like this, alright, in the east direction, even then its weight is 10 grams. If we keep it like this, even then its weight will remain the same. So weight is a quantity which has only the magnitude and not the direction. So that very quantity is known as the scalar quantity. Alright. Secondly, the representation. How do we represent a vector quantity? Supposedly, we have this vector. So this is the tail and this is known as the head of a vector. Like this is how we represent a vector. This is the tail of the vector and this is the head of the vector. The very starting point. The starting point of a vector is known as the tail and the terminating point or the end point is known as its head. So this is how we how a vector is represented. But okay, so it's very much difficult to every time denote the vector like this, like always drawing this much big line and mentioning all these details. It could be hectic and this could be quite a tedious task. So how are we going to represent a vector? So this is how it is. From A to B. This is a vector from A to B and we put an arrow over it. So what does it show? This shows that it is a vector quantity and AB shows that the vector is from A to B. The starting point of the vector is A and the end point or the terminating point of the vector is B. I hope I've made myself clear till this. So stepping on to our fourth quantity, magnitude. So I don't know, but you must have heard this term n number of times. Just when I started teaching you this lecture. So this word magnitude, what does this mean? The magnitude. Magnitude means the measure, the length, the weight, anything which is measurable is a physical quantity and that measure is known as the magnitude. For example, what is my weight? Supposedly if my weight is 50 kgs, then the weight magnitude of my weight is 50 kgs. The weight of this marker is 10 grams, then the magnitude of this marker is 10 grams, right? Okay, so that was about the scalar quantity only. Now the magnitude of a vector quantity. How do we calculate the magnitude of a vector quantity, or what is basically a magnitude of a vector quantity? Okay, so this is the vector and the 10 units, right? 10 units is the length of the vector. So this 10 units were the length of this vector AB, right? So this 10 unit is the magnitude of the vector, right? The length, the measure of this vector is known as the magnitude. All right, now comes how do we represent a magnitude. So a magnitude of this particular vector is denoted by A, B, vector and a modulus. Why do we apply a modulus when we represent magnitude? Now, like when I have taught this chapter earlier, then students must have said, I don't know, like they never knew why this concept. They never knew this concept, why we apply modulus or mod when we are calculating the magnitude. The simple and sober reason after this is the magnitude, okay, the length, the weight, the anything which is measurable can't be negative, right? The length of this marker can't be negative, the weight of this marker can't be negative, my weight can't be negative, the length of this board can't be negative, right? So the magnitude can't never be negative, right? The height is never negative, the length is never negative, the breadth is never negative, the weight is never negative. So that's why we apply a modulus, so that the answer doesn't come in negative, right? So we never say that the value of this is less than 0, because it can never happen. The weight can never be 0, the length can never be 0, the breadth can never be 0. So that's why we apply a modulus here, because this quantity can never be negative or less than 0. So we don't have a point discussing this thing. This value is always greater than 0. Alright? Okay. Now comes the main topic, which is the position vector. Now, what is a position vector? So, before stepping on to the position vector, I want to make a figure for you. Okay. So, this is, we have a 3D figure, a 3-dimensional space. So, this is the x-axis, this is very much the y-axis, and this is very much the z-axis, or people call it the z-axis also, but z is how it is pronounced. So the x-axis, y-axis and the z-axis. So supposedly from the origin, this is the origin, which is 0, 0, 0, and if we draw a vector from this very point, from the origin, which is perpendicular to x-axis, y-axis and z-axis. So if we draw a vector from the origin which is perpendicular to all the 3 axes, right? If we have this axis, then, and this is the origin and this is the position vector, such that this is the position vector such that it is perpendicular to the x-axis, the y-axis and the z-axis. So this is how the figure is. If we draw a line, okay, so this line is not appropriate, sorry. Okay. So this is a position vector, right? This is a position vector. This is the y-axis, this is the x-axis and this is the z-axis, and this is something like that. The OP, this is OP, the position vector. This is the position vector which is perpendicular to the x-axis, the y-axis and the z-axis, right? So this is how we denote a position vector. A position vector is something which is perpendicular to all the 3 axes and it passes from the origin. I think I've made myself very much clear. So this is the position vector and its points are known as x, y and z. Okay, so here OP is the position vector. So further we'll read n number of types of vectors. There are so many types of vectors, and this position vectors is one of them. So we are going to represent it by the same representation as we represented the normal vectors, because obviously this is also a vector, right? So this is the position vector. Now comes the angles. So the angle this position vector makes with the x-axis is known as alpha. This is alpha. The angle the position vector makes with the x-axis is known as alpha. The angle this position vector makes with the y-axis is known as beta, and the angle this position vector makes with the z-axis is known as gamma. So this very angle is gamma. Alpha is the angle the position vector makes with the x-axis, beta is the angle the position vector makes with the y-axis, and gamma is the angle that this position vector makes with the z-axis. Alright? So, it's not compulsory that we are going to make x over here or y over here or z over here. So, we can change the axis up to our needs or up to our wish. But, this alpha will always be the angle with the x-axis, and beta will always be the angle of position vector with the y-axis, and gamma will always be the angle with the z-axis. Alright? So I think I've made myself clear up to this. Thank you.